Now, let's explore how we're going to optimize our EBS volumes. And to start with, we'll look at monitoring the performance using Amazon CloudWatch. And this service provides real-time insights into the performance of your EBS volumes. Then we'll look at AWS Compute Optimizer. And this analyzes volumes and offers optimization recommendations. And then finally, we'll look at the elastic volume feature of EBS, which allows you to modify your EBS volumes on the fly. Okay, so now let's just have a look at how we can monitor our EBS volumes. And for this, we'll use the Amazon CloudWatch service, which is a monitoring service that provides the metrics of our EBS volumes. And what we're going to do here is we're basically going to look at a workload that I ran on this volume, and we're going to analyze the metrics to see how that volume performed against that workload. So as you can see on screen here, I've got a GP2 volume. It's 25 gigs in size. So remember, with a GP2 volume, its performance is tied to its size. So because it's under 1 terabyte, it does have the ability to burst. So its baseline IOPS, as we can see here on screen, is 100. But when it has the available credits, it can burst up to a maximum of 3000 IOPS. And this is available for 30 minutes, so long as those credits are in that bucket. Now, if the workload exceeds this threshold, so basically eats all those credits, what's going to happen then is the volume is going to be limited to that 100 IOPS. Doesn't matter how much the application is pushing at the volume only has the ability to process 100 IOPS at a time. So if we to look at the metrics of this volume, we scroll down to the monitoring tab. So with an EBS volume, any storage device really, there's 3 metrics that I would start off with analyzing when I'm looking at a volume to see if it's performing as we want to for that volume types. So the first one is the IOPS. So this is the amount of operations, so the read and write operations that the volume can process per second. And for this, we would look at our read operations and our write operations. The next thing that I would look at is the throughput metrics of the volume. So this is the amount of data transferred to and from that volume per second, and it's measured in megabytes per second. And for this, we have our read throughput and write throughput. In CloudWatch documentation, you'll see it as volume read bytes and volume write bytes. And then we also need to look at the latency. So this is the time it takes to complete a single I/O operation. So from the time the I/O is sent from your application or your operating system over to the volume. And remember, EBS is a network attached device, so it has to go from the EC2 over to the EBS network. The EBS then has to process the I/O and then send the acknowledgement back to EC2, basically saying the I/O is completed. And basically that's the latency. So for lower latency, it means we will get faster response times, and this is critical for your real-time applications. If you've high latency, this could actually indicate there's a problem, maybe there's too much workload for the type of the volume. You might not have enough IOPS or throughput for that volume type, and this is what we're basically going to look at now. Also, another metric, because it's GP2, you also do want to be aware of the burst balance. So remember, this is related to the burst credits. At the moment, this volume has 100% burst balance, so it basically has all of its credits to use. So what we want to do here is we want to dig a little bit more into these metrics. So what we'll do is we'll go into the CloudWatch service itself, and we'll look at those metrics for this volume. So I'm just going to copy the volume ID. I'm just going to open up the CloudWatch service. So what we want to go to is down to all metrics, and we're going to be looking at the EBS metrics. Before I do that, I'm just going to go to the time frame for when I ran this workload. And then we're going to go into the EBS volume metrics. We're going to look at the per volume metrics. So this is for this specific volume, and we'll copy in the volume ID so we can search that. What I'm going to look at is the IOPS that was run on this volume at that time. So we will also look at the burst balance, so I'm going to tick that as well, and we're going to see how the IOPS affected the burst balance. We'll take the write ops and the read ops. Okay, this may not make a lot of sense at the moment. So basically, when we look at it, if we just hone in here, basically we can see at around 15:45, that's when the workload started. And then when we see a flat line like this, generally with CloudWatch metrics, a flat line like this means you're hitting some sort of a limit that could be basically we're hitting the IOPS limit here for this GP2 volume. So here we can see that the volume write up, so there was no read in this workload. I was only sending write operations to this volume, and basically 180,000 operations is what was done. With EBS metrics, you get 1 minute metrics by default. So in order to know how many operations were done per second at this time, what we need to do is we need to basically divide that 185 by 60, and that would give you 3,000 operations. So you can see that's actually performing 3,000 operations per second. And this is it was doing the 3,000 operations from 1550 to 1610. So for those 20 minutes, it used the burst balance. And you can see during this time that the burst balance in blue is actually starting to drop. And once the burst balance went to 0, you can actually see that the number of write operations, that the volume is actually starting to decrease. So remember, because those burst balance credits are being used, that means once they're all gone, you'll have no more credits. So you're basically limited to the baseline, which is 100. So if you divide that 6,000 by 60, you're going to get 100, which is your baseline. So this basically shows that this GP2 volume, while it comes with a baseline of 100 IOPS, it could actually burst to 3,000 IOPS with those available credits, allowing it to reach that higher threshold. Now, we could see here that the workload actually wanted to push more, but it wasn't able to. So you'd basically start to see the latency going up during this time. So what you could do here is you'd need to go back and look at your workload. What I would recommend here is actually converting this volume to a GP3 volume, because by default, a GP3 volume will give 3,000 IOPS and 125 megabits of throughput as its baseline. And that's just consistent. There's no burst credits involved there after this, and that comes with no extra fees. So you can then convert that to a GP3 volume, and then you can provision additional IOPS throughput as needed. What I would recommend doing is running further benchmarking tests on the GP3 volume in order to understand your workload. And what I'll move on to next is I'll show you how you can actually modify this GP2 volume to a GP3 volume, and then change the IOPS and throughputs as necessary. And this time I have a GP3 volume that's 10 gigabytes in size, and I've provisioned it with 5,000 IOPS and 700 megabytes of throughput. So this is above its standard 3,000 IOPS and 125 megabytes that come with the volume that you don't pay for. It's included in the price of the GP3 volume. For the additional IOPS and the additional throughput, I will pay extra, and that's documented in the EBS pricing page. So let's go to CloudWatch and have a look at the workload that was running on this volume. For this time, I'm going to look at the throughput. So for this, we're looking at the volume write bytes and the volume read bytes. So as you can see, these metrics, these are 1 minute metrics. They're showing the total number of bytes. So this is the total throughput in bytes. And in order to get a more readable format for us, what I'll do is I'll use an expression in order to calculate the throughput. And to do this, we'll add the volume write bytes and the read bytes for the time period and divide it by 60 seconds to get the throughput for that minute. So what we do is we come into the graph metric section, select the drop down, and what we want is an empty expression. And we're going to use this expression here. So this is basically M1 and M2, which is your volume write bytes, your volume read bytes. We're adding them together and we're dividing by the period, the time, which is 60 seconds. And then we're going to divide that by 1,024 twice, or you could do to the power of 2, and this will give you the throughput for that 1 minute each time in megabytes. So if we come back up and have a look, and here we can see the expression is giving 500 megabytes of throughput. So if we come down and if we change that, if we just relabel that to throughput. So let's see here, we could see that at 16 minutes past 9, it was doing actually just over 500 megabytes of throughput. But if we look throughout the time frame that this workload is running, we're not actually achieving the maximum throughput. And remember, with that GP3 volume, it has 700 megabytes of throughput. So there's actually just over 200 worth of megabyte that isn't actually being achieved by this volume. You can see some dips here and some spikes. But generally for this workload that was running, so from just after 10 to 9 at night until 9:30, so we can see it's kind of basically level, and it's hitting between 460 and 500 megabytes of throughput, but it doesn't get any more than that. And then after that, we actually see while the same workload was running, there was nothing changed with this workload. It was the same test running for this whole time. we actually see it just drop, and it just sharply drops here. And then again, it's limited to just under 150 megabytes of throughput. So it goes from just around 500 megabytes of throughput and then drops to under 150, so just over 135 megabytes of throughput. With a line like this, when it's generally consistent, that means generally it's a flat line, but we can kind of see over these 1 minute periods for this time frame, it's not achieving any more than 500 megabytes of throughput. So what that is telling us here is that this volume is actually being limited. But if we have a look back at the volume, it actually has, as I mentioned, 700 megabytes of throughput. And the reason for this is it's actually the instance, it's the EC2 instance that's actually limiting this volume. So if we have a look at this instance, it's an M5X large EC2 instance. Now this is an EBS optimized instance, and what a lot of people actually don't realize with EBS optimized instances, for the smaller sizes, they have a burstable capability of throughputs. It's the same principle as how a GP2 has bursting, but with EBS optimized instances, they are able to burst at the throughput level. So if we open up the EBS documentation related to this will actually explain what's going on here. So this M5X large, and as we see here with this note, if we come up here, this is actually the behavior of what we're seeing. So this M5X large instance, this can sustain its maximum throughput performance for 30 minutes once every day. After it uses this 30 minutes of throughput burst, it then will be limited to its baseline performance. And we can see here that in terms of the throughput, it has a baseline of 143 megabytes, and then it has 593 maximum. So this is the behavior that we're actually seeing with this volume. So if we go back to the volumes, we can see that it's just hitting around that 500 megabytes of throughput. And how you can kind of determine this from the EC2 side is if we look at the CloudWatch metrics for the EC2 instance. So if we open the instance, this is the actual instance that the volume is attached to. And what we're looking here is at the byte bounds. And we can actually see that here. So this is the time frame. So that just under 100% of its throughput burst balance at the instance level. So basically, while the workload is running, it started to use those credits, and then it started to drain those credits. And this is at the point at 9:30 at night, the volume was then limited. So it ran out of credits and it was then limited to those 143. But because of the IO size, it actually only achieved 136, and that was to do with the IO, which will impact the IOPS and throughput of your volume. Again, remember, IO size, throughput, and IOPS, they're all interrelated and they do all affect each other. And with the workload that I was running, it had a slightly larger IO size, which is going to impact the IOPS and throughput that was running. So as we can see from these graphs, this is actually what's happening with this volume. So while the volume has 700 megabytes of throughput provision to itself, its actual EC2 instance only has 590, so under 600 megabytes of throughput when it has burst credits. And remember, it can only achieve that maximum throughput for 30 minutes once a day. After that, it's only going to be able to reach 143. So while your volume has all that throughput, it can never reach it because it's limited by its EC2 instance. And this is something to be aware of when you're actually thinking about which storage class of EBS volume to use. So in this instance, what you could do, we have 700 megabytes of throughput. So what I would recommend here is actually upgrading to a larger EC2 instance that doesn't have a burstable throughput, but something maybe like an M5 large. So you want to use an EC2 instance that has a larger throughput than the EBS volume, because remember, the throughput of an instance is going to be shared amongst all the attached volumes. So you're going to want to check what throughput each volume is using, and then you're going to compare that with the EC2 instance that it's attached to. So in this case, we would want to modify that EC2 instance to an M5 large, and that will allow the volume to reach its full potential of 750 megabytes of throughput, and it won't hit that EC2 threshold here of 850 megabytes of throughput. So just to explain what Compute Optimizer is, if you haven't come across this service, it basically analyzes different AWS services to provide you with right-sizing recommendations. And this includes your EC2 instances, your EC2 autoscaling groups, your EBS volumes, and also Lambda functions. And today we're going to look at how Compute Optimizer provides recommendations for your EBS volumes. So Compute Optimizer, it's going to analyze the available EBS CloudWatch metrics of your current volumes that are attached to EC2 instances. and then make these recommendations. And these recommendations can help you decide whether you need to upsize, so that's increase the IOPS or maybe increase the size of your EBS volumes, and also downsize your EBS volumes. So a thing to note with EBS, you can decrease the IOPS, but you can't. AWS does not natively support reducing the size of an EBS volume. In order to do this, you would need to create a new EBS volume of the smaller size and then migrate the data over from your original volume. So let's look at some recommendations that Compute Optimizer can provide for our EBS volumes. Okay, so let's look at the AWS Compute Optimizer service in order to get the recommendations for the volumes that I have running in my account. So if we open the AWS console, and you can see here that I've recently used Compute Optimizer, but you can't find it from the search bar if you haven't used it before. This is an opt-in service and it's free to use. So you do need to opt in, and basically when you're using this service, it generally takes a few days in order to set up and to analyze the workloads. And I generally recommend allowing it to analyze your resources for between 10 to 14 days in order that it gets a good idea of the workloads running on your volumes before you start looking at these recommendations. Okay, so what we're going to look at is the EBS volume recommendations. So we can find these down here on the side menu. So if we click into that, and you can see here that we're looking at the volumes in the Ireland region. And this is just about a volume that was deleted, so we don't need that anymore. And you can see here that we've got a number of volumes, all of different types and all of different sizes. And it's going to give us recommendations based on the findings for these volumes. Just to note that Compute Optimizer will only give the recommendations for volumes that are attached to instances. So make sure that if you're looking for recommendations for a specific volume, that it is attached to a running EC2 instance. Okay, so let's look at our first example, and you can filter your recommendations based on the tags of the volumes. So the first one we have, it's a GP3 volume. So if we click into the volume link, this is going to actually bring us to the recommendation for this specific volume. Okay, so we can see here that currently it's a GP3 volume, and it's got 80 gigs in size, and it's provisioned with 6,000 IOPS. And basically, Compute Optimizer is telling us that this volume, it's not optimized based on the IOPS that are provisioned. So with this volume, I have it provisioned with 6,000 IOPS, but this is for peak workloads. And in the past 2 weeks, the volume was never processing more than 3,000 IOPS. So basically, based on this, what Compute Optimizer is telling you, if we reduce the IOPS from 6,000 to 3,000, it's going to save you just over $16 per month, just by basically making that one small change. And this might seem not a whole lot amount of cost savings, but in a large environment where you could have hundreds of EBS volumes, and if you have volumes such as this that are over provisioned in terms of IOPS, removing these large number of your underutilized volumes like this would really give you a significant cost savings. Okay, so let's look at our third example of recommendations that Compute Optimizer is providing with us. And this time, we're going to actually look at two optimized volumes, and we're going to compare those. So as I mentioned, they're both optimized. One is a GP2 volume and one is a GP3 volume, and they've both 1,000 gigabytes in size. Now you may be thinking with the GP2 volume about the burst model, but do note the burst model only applies to GP2 volumes that are smaller than 1 terabyte. So this volume, it's 1 terabyte in size. So basically its baseline is 3,000 IOPS, and this is the maximum bursting capability of a GP2 volume that's smaller than 1 terabyte. For a GP2 volume size at 1 terabyte, the bursting model no longer applies, as its minimum IOPS is basically the same as what the maximum bursting capability is. So if we just look at these two volumes that are optimized, the GP2 volume actually costs you $110 per month to run, and you're getting that 3,000 IOPS. But the GP3 volume, the general purpose tree, also 1 terabyte in size, is actually cheaper to run at $88 per month. So for this GP2 volume here, it's actually costing you more to run for the exact same spec. So if you were to change this GP2 to a GP3 and don't touch the IOPS, you're actually going to pay less and save yourself just over $20 per month, which is that 20% savings that AWS mentions in the documentation by converting from GP2 to GP3. So for any of you that are out there currently running GP2 volumes, my recommendation and AWS's recommendation is just to modify those volumes to GP3, because you'll instantly start saving volumes for basically better performance and better capacity requirements for those volumes. Let's take another example here, and we've got two optimized volumes. And what you'll notice here is these volumes are costing us the exact same to run. So they both cost us $8.80 per month to run. However, one is a GP2 and one is a GP3. So by changing that GP2 to GP3, you're automatically going to save 20%. But in this case, they're costing the same amount to run. But what you will find here is you will increase the storage and increase the performance. So as we can see here with the GP2 volume, you've got it at 80 gigs and it's costing $8.80. But with the GP3 volume, you actually get 100 gigabytes for that same price, and you get the 3000 IOPS as standard. With the GP2, because it's under 1 terabyte, it has a minimum IOPS of 240, and it can burst the 3000 IOPS, but that is only while the burst credits are available. So once those burst credits are gone, you'll no longer be able to reach that 3000 IOPS, and then you'll be limited to the baseline IOPS, which may not suit your workload. So really, this case, it's a no-brainer. While you'll be paying the same by moving to GP3, but you will get increased storage and increased performance just by making that one small change. So if you are running GP2 volumes, my recommendation would be to just straight away modify them to GP3, and you're going to save yourself 20% in cost, or you're going to be able to increase your storage and possibly your performance. So elastic volumes, this is a feature of Amazon EBS, and it allows you to dynamically modify the size, the performance, and the type of your EBS volume. And this is done without any downtime or impact to the performance of the volume. So if your workload changes or your requirements change, you can use this feature, elastic volume, to modify the type of volume, increase it in size, or change the performance while the volume remains online and active. And just to note here, with EBS volumes, you can't use this feature to reduce the size of the volume. So in order to reduce the size of a volume, which is not natively supported by EBS, what you need to do is you would need to create a new volume of that smaller size and copy the data over from that original volume over to the new volume. So with elastic volume, this means you can adjust these parameters as your application's need change without having to recreate the volume and restore data from a snapshot. So let's have a look at how we do this in the EBS console. So here we have our GP2 volume, and as you'll notice, it's from our CloudWatch lab. So we've seen that this volume, it's 25 gigs in size, so it does have those burst credits. And as we've seen from the earlier episode with those CloudWatch metrics, that volume was actually hitting that 3000 limit, and it did sustain that close to the 30 minutes. So with this volume, we're regularly seeing that the volume is hitting that 3000 limit. So what we can do is here, we can actually modify this volume. And as we discuss in a later episode with EBS volumes, the newer type of general purpose is GP3 volumes, which are recommended by AWS and are actually cheaper to run, as we've seen in our earlier section with Compute Optimizer. So let's have a look at how we actually modify this volume. So if we go and click on modify, and we're going to change this volume to GP3. So with a GP3 volume, it's actually 20% cheaper to run. And as standard in the price of the volume, it includes those 3000 IOPS, and it includes the 125 megabytes of throughput. So because this volume is always hitting that 3000 threshold, what I'm going to do here is I'm actually going to change it to 4000 IOPS. And I'm going to modify that volume. So we're changing this type from GP2 to GP3. We're keeping the size the same. So as I mentioned previously with GP3 volumes, you can independently provision the IOPS and throughput separately from the size, which we're doing now. So let's modify this volume. And now let's go back in and we'll have a look at it. So we can see here that this volume state is modifying. Now, just to note, with the elastic volume feature, there's no SLA on modifying times, and we'll discuss that later as a common pitfall with EBS. So do be aware that AWS does not provide any time frame for when this operation will complete. It does depend on the volume itself. And just another limitation to be aware of when you're modifying volumes, you can only perform one modification at a time on an EBS volume. As we're modifying this volume now, in order to make any further changes through the elastic volumes feature on this volume, we would need to wait at least another 6 hours before attempting another modification. Okay, so our GP2 volume on the console, the modification has actually completed. On the volume console, we can now see that the volume is a GP3 volume, and it's provisioned with 4,000 IOPS and 125 megabytes of throughput. It's attached to the instance and ready to be used. So as we've modified this volume once, we now need to wait 6 hours before we can modify the volume again. So if we go to modify the volume, let's say we want to change back to GP2 and we click modify the volume. So go ahead, click modify. And as you can see here, the modification volume failed. And you can see here the error message is telling you why. So you've reached the maximum modifications rate per volume limit. So we must wait 6 hours between modifications per volume. And this is a hard limit set by the EBS service time, and there is no way of getting around this other than basically if you have a snapshot of the volume and you launch a new volume from that snapshot, you can specify the type, the size, or the IOPS as required. That's the only way to get around this limitation. Other than that, you would need to wait the 6 hours in order for that limit to be removed.